what you're putting in. All your hopes and efforts are all in vain. Who will pick you up when you've lost everything?
And welcome everybody to the Keith Barker channel here on YouTube. It is great to have you. If you are just joining us, welcome. My name is Keith Barker. I'm a double CCIA. I've got my first CCIA Cisco Certified Internet Network Expert back in 2001. Got another one in 2003, and I've loved Cisco technologies ever since. The objectives for this channel and for this video are pretty simple. I want to provide you with the best tools and tips today that you can use towards getting your CCNA. And part of that involves building and hands-on practice. I had a Kahoot session, a quiz session on Sunday. I had those at Sundays at 11 a.m. every Sunday. And one of the questions I asked was, what is one of the most vital aspects to really mastering and learning this technology? And the major answer was hands-on practice. I totally agree. Now, as far as a tip or a technique, how can we get that hands-on? And there's three basic ways of doing it. One is you can buy the physical gear. Nothing wrong with that. We can buy the physical gear like used on eBay and such and put it all together. It is a lot of fun. In fact, somewhere back here, this is my cue card for today. Take one. Take one and done. That's all we're going to do. So anything that comes up in the video, the camera is rolling. One second. So I recently bought some gear, and I bought some like little 3560s that have no fans, so they're more quiet for the office and so forth, and some wireless LAN controllers and an IP phone and such. And I've had a lot of fun with them, and that certainly is an option. Oh, bang. Solid state. Hopefully it'll be okay. Back in the day, like a decade ago, 2 decades ago, that was the only option, is to have physical gear. But now we have other options, such as virtualized options. So if you want to get a free copy of Packet Tracer from netacad.com, you just go to netacad.com, Cisco site, sign up for a free account, get it for free. Tons and tons of Packet Tracer labs. In fact, let me show you, share screen with you real quick. And let me bring this up. All right. Hi. So one of the labs we did, we connected a home lab that you could do by purchasing gear to the internet. So here's the internet, here's my cable/DSL router, whatever you happen to be using, my home router, and my home network. And then I recommend not putting all your gear directly on your home network as far as all connected to that same network, because you know what I discovered is that there's a lot of people probably at your house that absolutely don't want interruptions to service. So one idea is to go ahead and put the edge of your home network, your home lab that connects to your home network, and then have everything else isolated, so you can have spanning trees just go berserk and all these other kinds of things, and it won't harm your home network because it's considered to be a production network. So we had a video on that, and if I bring up this real quick, just want to remind myself what that video was. Here it is. Yeah, it was called Connect Your Home Cisco Lab to the Internet, and you can find that on my YouTube channel. So, wow, 8.4 million views. That's good. And 104,000 subscribers. I love it when we can make a difference, give you the best tips and tools for getting your CCNA. So I appreciate you participating and watching. If you find any value in this, please give it a thumbs up. And so this is that video. And then I had people say, well, I don't have all the gear, and I want to practice. I want to practice DHCP and NAT and VLANs and static routes and OSPF and so forth. But how do I do it without a real home lab? And the answer is this video right here, Packet Tracer Home Lab to Internet Simulation. So you can watch this video, and the links for the description there are in the description. There's links that you can download this lab and walk through it. So whether you're doing physical gear or whether you're using virtualized gear, the big key is that you want to make sure that you're practicing hands-on. When you're learning something, practice. All right. And since I've got it right there, we could also have a little fun like this. Make that mustache a little darker. Give myself a little more beard. All right. So what I want to do in this video is I'd like to share with you how we can do that same lab again, but this time using Cisco Modeling Labs with the Personal Edition, which it's a commercial product. You have to buy it. It's like $200 a year, but it's fantastic. So if you want to use that instead of Packet Tracer, I just wanted to give you a demonstration of a tip of how to get a Cisco Modeling Lab network connected to your real network, including the internet. Imagine having your lab and being able to, from your Cisco Modeling Lab or Packet Tracer Lab, well, can't do it with Packet Tracer, but your Cisco Modeling Lab, to get full connectivity out to the internet. So I'm going to use the same topology as we had before. And let me bring that up. It's right here. And let's just do this, but this time we'll do it in CML, Cisco Modeling Labs. And if you want, for tips on installing the basics of Cisco Modeling Lab, I got to give a huge shout out to David Bombal. He has a great video on how to, from downloading, installing, and setting up Cisco Modeling Labs, the personal edition. It's fantastic. So I didn't tell David I was going to give him a shout out, but it's a great video. You should go check it out, subscribe to his channel, and he's got a lot of great content. I trust David Bombal. He is very thorough, meticulous. I love it. So I've got Cisco Modeling Labs already set up. I would like to share with you a couple details that will help you if you are using Cisco Modeling Labs. And it'll look like something like this. What we'll do is so here we have the home network. That's physical. And then we'll add our, let me change my color there so we can see it. Let's add R1 in Cisco Modeling Labs. So everything from here over will be Cisco Modeling Labs. And we'll bring R1, our switch, we'll connect them together, and we'll do the configuration. And then I'll walk you through how we can take this network, this Cisco Modeling Lab, and connect it. I want to say physically connect it to the home network and have the same functionality. So this router and this switch and all the other devices here can get access to the internet. It is so fun. I love it. I also love this. I love the fact that CCNA is a stepping stone. And I love it when people jump in, they focus on the technology, they learn it, they practice it, because you can use those skills that we're learning in CCNA, and you can apply those as you continue to grow your career and get into the world of IT even further. So I've always, I don't know, my whole life I feel like I've been an underdog. I still do. I feel like, wow, people think faster than I do. It's true, especially as I'm a little older now. So I have more wisdom, but I don't think as fast. And you may be saying, Keith, you're talking pretty fast. So, but reality is that I've always felt like a position of underdog. And CCNA for you can be a great stepping stone to greater things that and beyond. So get the foundations down, and no matter where you're coming from, if you've got internet access and you can get Packet Tracer for free, you can watch my Packet Tracer labs, you can do the hands-on practice, you can learn the technology, you can master the technology, and then go on to additional things, cloud computing and CCNP level topics, security, cybersecurity, pen testing, whatever else you want to do. But this is a really important stepping stone. And from my heart, I've always felt like I want to help, millions of people come from a point where they don't know this technology, where they do know it, and then they can use that as a stepping stone as they go to bigger things. I feel really important about making that difference. So thanks for watching this video. Let's take a look at Cisco Modeling Labs and how we can connect our home Cisco Modeling Lab network to the live internet, and I'll walk you through the steps. So let's start off with a couple important pieces, and that would include this. I am currently using VMware Workstation. You can also do this with VMware Player, and any way you want to do it's fine. And what I did was I just followed the instructions on installing Cisco Modeling Lab. But one of the things that I want to do is I want to share with you behind the scenes what I'm doing for networking. And here in VMware Workstation, you click on Edit, and then click on Virtual Network Editor up here on the top left. And then you click on Change Settings right here. And that lets you modify. That just gave me a prompt for authorization for that. So it didn't bring up that window, so I'm going to go back. Oh, maybe it did. It's hidden. There we go. It was just hidden. So now that I can edit it, here's one thing I would encourage you to do. Is VMnet 0 by default is going to bridge, meaning like a layer 2 switch. It's a logical layer 2 connection between VMware Workstation and your actual physical network. But check this out. If you have lots of networks, like lots of network adapters in your computer, which one is it going to choose? Hopefully it'll choose the right one. I think to avoid problems, you want to hard code that. So I'm clicking VMnet 0, which by default is bridged to your network card, your Ethernet card, or your wireless, depending on which one you're using. And instead of saying auto, like I'll automatically figure out which card to use, I specified my actual interface. I have that model of network interface card. So I said bridge to that specific interface, and that way there's no guessing game. That VMnet 0 is absolutely tied to this card, and that's going to remove a whole bunch of frustration if you have multiple network interface cards. All right, so that's what I've done. I'm going to go ahead and I did not make any changes, so I'll leave that alone. And I also followed, oh, one other thing. For the virtual machine, I went to settings during the initial installation of it. And for network adapter, I didn't say just bridge, which is the default, bridge to the physical network. I said custom, use VMnet 0 because I like tight networking. I like networking that doesn't have a bunch of variables in it. So the network adapter for this virtual machine running Cisco Modeling Labs is linked to VMnet 0, which is hard-coded to my real Ethernet network card, so everything's nice and clean. All right. It's like therapy, getting that off my chest. All right, so I booted it up. It gave me this IP address, 192.168.1.203 for managing it. And I'm going to bring up a browser, and let's just open that up. So I just went to right there, 192.168.1.203. That's great. That's the IP address. If you go with HTTP, it'll redirect you to HTTPS, so you can go either way you want. And that's where I'm at. And let me bring this up full screen. I'm going to use F11. All right, so to create a new lab, and what we're going to do is build that same lab we did in those previous two videos, packet tracer and physical gear, but we'll do it here in the Cisco Modeling Lab. I'll give you step-by-step instructions. We've got nothing on the screen, no labs that I'm going to use. We'll build the lab from scratch. So let's go ahead and do it. Let me get my face out. My face is fine. All right, so I'm going to click on Add Lab up here. And here's the new lab I'm adding at. So the time zone isn't my local time zone. I can live with that. We'll call this Home Lab to Internet. Great. And then we'll click on it, and that brings it up. So I've got this fresh, green field network design that just nothing here I can just start playing with. So let's go ahead and bring over a router. Over on the right, I'm going to grab iOS V. That's just a virtualized iOS router. And I'm also going to make it bigger. Up in the top left, I'm going to click on zoom in a few times. Many times. And also, I'm going to click on this little icon right here, which is center view. And that way, it just kind of centers it for us. Well, actually, I'm going to drag it over. And once I have a few devices on my topology, I'll use that center view again. All right, let's go ahead and I'm going to double click on that and rename it. And let's call this Router 1, because that's what it is. All right. And for the details, for like the step-by-step and how does iOS work, check out my other videos in this playlist or whatever you're using for your main course of study. My goal here is to show you how to do Cisco Modeling Labs, connect it to your physical network, and verify it's working. Let's bring out a switch. I'm going to grab the Cisco IOS VL2. That's the virtual layer 2 switch. And I think in the previous videos, we called that switch 1. And we may need to look back at the topology just to verify that is what we called it in all the interfaces. So there it is. And let's connect them together. The way you connect them together is you hover, and then this icon for a link, just click and hold, and then drag over to the other device. And then it specifies, okay, what ports do you want? And I'm going to use gig 0/1 to 0/1 because that's what we used inside the other two previous videos. And you can verify that by clicking on, let's see here. Where is that at? It's not running yet. I was hoping it's going to show us the connections. All right, so if I click on one of these devices while the lab's not running, and I click on connectivity, it's going to show me where we're connected from the switch 1's perspective. All right, so we've got switch 1, router 1, and let's also, while I'm here, let's bring up the external connector. This external connector is how we connect to the external network. And I'm going to go ahead and click on that a couple times and go to node info, and I'm going to call it home real network, which is the 192.168.1 network in my case. And I've got my little home default gateway at 192.168.1.1. Great. Now, before we leave that device, I'm also going to add some connectivity. So I'll go ahead and click on the link icon and drag over to R1. And to be consistent with our diagrams from earlier, let's go to gig 00. And we can click on that real home network. And I want the connectivity. Click on R1. All right, I need to practice a little more. Once this is running, oh, I'm no longer selected on the router. Okay, I'm not going to spend too much time. Once it's running, we can look at each of these devices and it'll show us all the connectivity involved. All right, a little frustrating. I'm okay with that. It's totally me. That's totally my fault. So there's our one, connectivity. All right, so I'm just going too fast. So click on the device, click on connectivity. It'll show you the ports involved. And I must have clicked away, which is why it didn't show me that for each of the devices. All right, so we've got connectivity gig 0/1 on switch 1 to R1 and gig 00 going to my home network. Now, before I actually start this up, I'm clicking on the home network. This is important if you want this to work the way that I intend it to work, which is bridging out to the physical network. By clicking on the home real network there and going to edit config, we want to configure it as an interface type of bridge before we power it on. Because if you power it on, then it's going to complain it's running. You got to bring it down, wipe it, and start over. So the real home network I'm setting up in bridge. And you know, while we're at it, because we're here, let's also bring out a server. So there's an Alpine Linux box. So I'll go ahead and change the name on that. Call it Linux. And let's connect him to a port. So I'll click on the Linux box and click on the link, and let's put him on. So, wow, he has a lot of ports. Let's go ahead and use Ethernet 0 on the Linux box, and let's go to gig 02 on the switch. Great. Okay, so our basic connectivity is in place. Let's power these things up. There's some options for preloading a whole bunch of configs. I'm going to take it from the ground up, just from scratch. So I'll click away. So I'm not selecting any of these specific devices. Go to simulate, and I'm going to click on start lab. And there's a little icon next to each one of them indicating that they are powering up. And it may take a few moments for that to happen. Perfectly fine. While that's coming up, let me bring up my notepad document with a lot of my favorite commands. So I will copy those. These apply to switches. They don't. There's a few commands for routers that there's a few switch related commands that won't apply to a router. I'm just going to leave them in. I'll take the errors for those things like VTP domain. The router says, I don't know what that is. Or spanning tree mode. I don't know what that is. I'm just going to paste these in on all the devices. All right. So I'm going to right click, copy that. And if we, now that it's running, if we click on the switch and go to console right here, this little console icon, and I will bring this up a little bit. And on the console tab here, I'll click open console, and it's still initializing, which is fine. Over here on the right, under columns, I'm going to click on auto, and that'll give me more width. Fantastic. That's booting up. The Linux box, let's go ahead and go to console for that. All right. And I'm going to log in as admin, no, root. And hopefully it's Cisco. Yay, we're in. And I'm off the screen. Let me hide my taskbar. Taskbar settings, and let's go ahead and tell it to automatically hide. All right, great. That'll give us so we can see at the bottom there on the bottom left. And let's do a IF config. Great. It has no IPv4 address because we don't have a DHCP server. We haven't configured that yet. No worries. We'll come back to him in just a moment. So on switch 1. Let's bring out my notepad document here. Give me one. Oh, it's hidden. Great. I hid my taskbar. Like, where's my taskbar? All right, we'll grab that and take it, and we'll just go to switch 1 to the console and make sure we're in the right starting point. All right, go into privilege mode, and I'm just going to right click and paste. And boom, we're good to go. So this switch is, I'll call it switch 1. Do a quick right. Fantastic. We'll go to R1. And we'll go to the console. I'll say no initial script. And then we'll just paste in that command as well. Paste in the config. All right. Wow. It's live iOS. And great. Fantastic. All right, mister. While you're cooking on that, let's go ahead and bring out a pen. Let me talk about our plan. So here's what I intend to do. This is the 192.168.1 network. And we're going to do .11 here, a default gateway going to .1, which is my home router. And here we'll have, this port will be VLAN 1. VLAN 1. And we'll make interface VLAN 1. and we'll give the IP address of 172.16.1.200, and we'll give this guy the IP address of .11 on the 172.16.1 network. That way it'll be consistent with the previous two demos. And we'll set up OSPF between these two. We'll tell R1 there's a default route going to the real internet with .1 as the next hop. And let's put this port right here, which is going after the Linux box. Let's put it in VLAN 10. And let's use the address of 172.16.10.0 here. And that means we'll also create a virtual interface on the switch for VLAN 10. And let's give it .200 there. How much time do we have? Let's also set up a DHCP server on this multi-layer switch so that it can hand out an IP address to this Linux box. And we'll also need to do NAT here on R1 if we want this private network of 172.16.10 or 172.16.1 as traffic goes out to be translated to this local network so my home router knows how to get back to them. So we'll set up NAT here as well. And then my home router, as it goes out to the internet, is also doing a little bit of PAT. More details on all those nitty-gritties in the previous two videos on connecting your home network to the internet and also connecting the Packet Tracer Lab to the pseudo internet. All right, so that's our plan. And back to the router we go. Bring up Notepad again. And I'm going to copy that. Go into privilege mode. Paste this in. It'll bark at the commands related to switching. That's fine with me, and it's going to be called R1. And we'll do I'm going to save it as we go. All right, let's configure the interfaces. Gig 00 is here on the right. So we'll do we're already in configuration mode. Interface gig 0/0. No shutdown. IP address 192.168.1.11 with a 3-octet mask. That looks fantastic. Let's do a do ping to 192.168.1.1. I just want to verify that I can ping my default gateway. And the crowd goes mild. At least I did. Great. That is this router, R1, pinging my default gateway on my home network. Fantastic. Let's also set up a static route, a default route, IP route. And what is the syntax for a default route? What is that? Do you recall? If you're thinking I had a whole bunch of zeros in it, you'd be spot on. It's quad zeros followed by quad zeros. And then the next hop, which is going to be 192.168.1.1. And we'll do a do show IP route just to make sure we have that static route. Okay, there it is right there. Fantastic. So we should be able to, R1 should be able to ping the internet. If we do a do ping, I'm doing the do because I'm in configuration mode. Do ping of 8.8.8.8. It's almost too good to be true. Let's do it again, and let's do a trace this time. Let's do a trace to 8.8.8.8, and that is going out to a Google DNS server through the internet. So the first hop is my default gateway right there, and then my default gateway is using a next hop through my service provider there, and so my little home router is doing PAT, and we're doing network address translation again somewhere in the service provider network, and then we're going out to the live internet with the IP address of 100 as another router in the path. Great. All right, we are halfway home. I'm going to go ahead and click on the center option here. I guess it's centered enough. If you want to move them all around, you just click somewhere in the free space and just drag, and you can put it anywhere you want. All right, so R1 has a default route. Let's configure OSPF to support the 172.16 anything. So to do that, we'll do a router OSPF, spelled correctly. Router OSPF1 network 172.16.anything with a wildcard mask that says that. And we'll put that in area 0. It's always a good idea to verify as we go. So I'll verify that our interface gig 00 is participating. Also, I want to source a default route. We'll do a default information originate. I'm going to say always in case I lose my default route. I can still advertise the default route. And then also while we're here on R1, we're going to need NAT. So we're going to need NAT because my little home router has no idea about how to reach the 172 network going this direction. So I'm going to make everything appear on R1. This will be the outside, this will be the inside. I'll make everything to this home router appears it's coming from this IP address. We'll just do a PAT, port address translation, with an overload on the outbound interface. This is great practice, whether you're doing it with physical gear, whether you're doing it with Packet Tracer, whether you're doing it here with Cisco Modeling Labs. It's all great practice. So let's go into interface gig 0/0, IP NAT outside. This is like live gear. Look at that. Trace backs are not good, not a good sign. So let me go ahead and issue that command again. IP NAT outside. I just abbreviated the out. And interface gig, wow, 0/1, IP NAT inside. All right, so the traceback, yeah, not good, but it looks like said CPU hog, something about, so if it doesn't work, we'll go back and revisit it. Live gear can sometimes do that to you as well. All right, tracebacks are a real thing, and they're never good. All right, so let's do a do show IP NAT statistics. And so I've got my interfaces confirming where I'm at. Let's create an access control list that'll specify who can be translated. So we have a couple options. We could do a named access list. We could do a numbered access list. Either way, it's going to be a standard access list that's going to be used not for filtering, but for simply identifying as part of NAT who should we translate and who should we not translate. So let's do IP access list standard, and we'll go ahead and call it for NAT. How about that? We'll permit anything that begins with 172.16. So the wildcard bits would say we care about matching the first octet, we care about matching the second octet, and we don't care about the third or the fourth octet. And there's our access list, do show access list. It's always important to verify as you go, because one little problem that you missed early on is going to mess up the results later. So I like to verify as I go. Good tip regarding practicing, getting things right. Do show access list. And when you're in the configuration mode and using the do command, there's not a lot of context sensitive help. So that'll also help confirm that you understand what the commands are, even without context sensitive help. Okay, there's our access control list. Fantastic. So we'll do it IP NAT inside source list. We'll call it for NAT. And spell that exactly correct. Case sensitivity is important. For NAT, and then we'll say we want to overload on the interface, and it's going to be gig 0/0. That's the outside interface. Space overload. So that's our NAT rule. It's in place, and we should be good to go. We can test that here in just a moment. So let's go back to switch 1, and let's configure switch 1. So I'll click on switch 1, click on console. That takes us to the console for switch 1, and the party begins. Show interface status. Not a bad place to start. All right, so all the 4 ports on the switch are in VLAN 1 by default. They're not routed ports, so that means the connectivity from R1 to the switch, R1's connected to an access port that's in VLAN 1 as an access port. I'm going to hard code that though, just so there's just for fun. Interface gig 0/1 switch port mode access, because this gives you a practice for the CCNA commands once again, and switch port access for VLAN 1. Hard coded now as an access port, and do show VLAN brief. Survey says, great, they're all in VLAN 1. Now let's configure an interface VLAN 1. And if you know the difference between VLAN 1 and interface VLAN 1, that's great. If you're thinking, I don't know what the difference is, check out the videos on multi-layer switches in the master playlist, and also switched virtual interfaces and how they work. So switched virtual interface and interface VLAN is a layer 3 logical interface that lives in the corresponding VLAN. So we'll do a interface VLAN 1, which I just did. Oh, I guess I didn't. Interface VLAN 1. So now we're in interface configuration mode for VLAN 1, for interface VLAN 1, and IP address is going to be 172.16.1.200. And what I would encourage you to, and I'm almost going to do a no shutdown. I see there's a shutdown message there. So I would encourage you to practice if you have a home lab, using the video regarding home lab to the internet. If you don't have a home lab, use Packet Tracer. Great, that lab is provided for you in the downloads. Go ahead and practice it. Or if you have Cisco Modeling Labs, you can use this method here. The key is practice. and the commands and the logic is the same as far as configuring the devices. Let's do a ping to 172.16.1.11. That's the IP address on R1, or it should be. I'm glad we tested. All right, let's troubleshoot. Why can't we ping switch 1 to R1? It's probably just me. Let's here back on R1, show IP interface brief. Oh yeah, look at that. So right here on this interface, on router 1, although it's in my diagram, it's not configured. Somebody once said it's important to have the configuration on the gear if you want it to behave the way you expect it to. So let's fix that. Config T, interface gig 0/1, no shutdown. That's important too. And then IP address is 170. Reconnect console. IP address is 172.16.1.11. Oh my gosh, my mouse got out of there. So IP address 172.16.1.11. I'll say it with a happier face. And the mask is a 3-octet mask. And it is already up. I'm going to just force a habit there. And let's do a ping to 172.16.1.200. All right. Now, spanning tree, if it was running and that port had just come up for the first time, it could take a moment for that. But we have connectivity now between switch 1 and R1. Let's do a show IP OSPF interface brief. Show IP OSPF interface brief because I'm no longer in configuration mode. Oh, come on now. All right. So it's considering life. In a few moments, there should be a neighborship. We'll go back to switch 1, verify OSPF is enabled there as well. Oh, it's not. Great. So router, OSPF 1, network. I'm going to bring in all the networks here because we're behind. We're in our internal lab networks, and I'm going to say bring everything in and put them into area 0. And if this comes up right away, so if there was a DR already set up, which R1 finished its wait state and became the DR, if it's already in place and a new router comes on, it's the second device, it'll form an adjacency right away. If you bring 2 up at the same time and they have to think about who's the DR or BDR and have that election and go through the wait cycle, it might take 30 to 40 seconds-ish for them to actually bring up a neighborship. But if you already have a DR present, the other one comes up, it should be very, very quick. Okay, and that's the kind of experience you get with labbing it up and practicing, whether it's packet tracer, whether it's live gear, or whether it's here on CML. All right, so let's do a show IP OSPF neighbor. Won't you please, won't you be my neighbor? Show IP route. This will verify the IP routing. Okay, yeah, it's definitely enabled. And also we have a default route that we learned from R1. So, okay, let's just check our work here. The play-by-play goes something like this. We've got a default static route going to .1. We've got NAT here. This is the inside, the outside. We have a NAT rule that says anybody coming from a source address of 172 anything can be translated. We have OSPF adjacency between switch 1 and R1. It's a full adjacency. Init, two-way, xstart, exchange, loading, and full. They did that whole process. Switch 1 has a default route pointing to R1. It's great. And let's verify that switch 1 can actually make it to Google. That'll verify all the pieces are working. And it's a great exercise. So whether you do this with Cisco Modeling Labs or Physical Gear or the free Packet Tracer Lab, I would encourage you to practice this. All right, let's give it a shot. Ping 8888. Trace route 8888. Sure enough. Look at that. Oh my gosh. I still get a big kick out of when lab environments, like if our practice environment, can connect to physical and live gear and everything works. It is amazing. And in the real world, man, half of our gear, especially servers, is virtualized. You know, virtual servers, and a lot of our networking gear is virtualized up in the cloud. But the concepts are the same. All right, let's go back. Okay, so we're almost done. We've got our connectivity out to the internet. Let's bring up a client and make sure it can do it too. Now, for this client to work, what I suggest is let's make a DHCP pool on switch 1 and have it hand out the IP address. Let me pen this up so this is for my benefit. So let's use for this port and I'll have to verify where that's connected. I think it's 0/3, but we'll verify that. Let's configure that to be in VLAN 10. So an access port in VLAN 10. Let's also configure interface VLAN 10. And let's use 172.16.10. And let's give the interface VLAN 10 the IP address of 200 on that network. And then we can, in our DHCP that we'll configure, we'll tell the DHCP pool that the default gateway for VLAN for that network is 172.16.10.200, so the switch can receive those and then make a routing decision. And then R1 will NAT, send it to my home router, it'll do NAT, send it through the service provider network, and we can have this Linux box in CML get full access out to the internet. I say full access. Does the whole internet come with that? I mean, internet connectivity. It reminds me of an old AOL commercial where the person said, now, if I buy AOL, does that come with the entire internet? The early days. All right, so let's go to switch 1. We're already here. Here's our console for it. Let's create, let's carve out. Let's first of all take a look at the interfaces. And this says gig 0/2. I was off by 1. So gig 0/2 is connected to our Ethernet box. So we'll put gig 0/2 inside VLAN 10. So back to the console, config T, and let's create VLAN 10. And interface gig 0/2, switch port mode access, switch port access VLAN 10. I'm using a few shortcuts there, but too many shortcuts there. Oh my gosh. Oh my gosh. I got my caps lock on. It's a nightmare. Caps lock off. Okay. Switch port access VLAN 10. Not so hard. All right. Then we'll do a verify. Do show VLAN brief. Great. So this shows us that gig 0/2 is in VLAN 10. We could also do a show interface status. That would also show us that information, which is great. And let's create interface VLAN 10. This is the logical layer 3 interface on the multi-layer switch. IP address. 172.16.10.200. I'm using the last octet of 200 for all the switch 1 interfaces. And a 3-octet on mask. Great. And a no shut. Important if you want it to work. It needs to be up. I just saw the down message. All right. And oh, let's make a DHCP pool too. So IP DHCP pool. Our pool. And we'll say network 172.16.10. Huh. Network. All right. 172.16. There's some other command that starts with net, so my bad. So 172.16.10.0 and a mask of 24 bits. One of the few times I can do it here on iOS. And so we'll use it. And let's do a default router of 172.16.200. Got carried away. .10.200. And we can also give him DNS if he wants. How about a DNS server? Let's go to 8888. Let's say, hey, use Google. Use a Google DNS server. Hopefully you can reach it. If everything's set up correctly, he should be able to. All right, exciting times. And let's check our work. So we'll do a show run section DHCP. There's our pool. It's for the 10 network, the 10 subnet. Default router is the layer 3 address of the multi-layer switch. DNS server is 888. That looks good to me. All right, so let's go to the Linux box. And we'll go to a command prompt there, or the console. And let's do a ifconfig for Ethernet 0. Oh, look. All right, so that seems almost too good to be true. Let's see if it must have been trying in the background to get an IP address, because that IP address it just got is in the range. Let's do a route, IP route. I don't see the default gateway though. So that's a problem. So it might have gotten the IP address before I put the default gateway in as far as the DHCP config, because I don't see it. So if it doesn't have a default gateway, it's not going too far. Let's do this. config, Ethernet 0, down. And I think there's IF down. Does that work here? Oh yeah. So IF down, Ethernet 0, that also works. All right, and then IF, you can do IF config, Ethernet 0 up or down, but you can also use IF up, Ethernet 0. That also seems to work here. And okay, look at that. It got an IP address. Let's do a route. And now it has a default gateway. I don't think that was there previously. All right, so it's important if we want this to work for it to have a default gateway. Let's do a full shot here. Let's do a trace out to, let's go to www.cisco.com. So the magic of this, let's take a moment. The magic of this is that if this is going to, I don't know if it's going to, I hope it's going to work. If this, well, we looked at all our pieces. I have pretty high confidence it's going to work. If this works, it's because the DNS worked first. So the DNS resolution is being sent, routed out to the internet, response is coming back, and then he figures out what the IP address is, the Linux box, and then he does the trace based on the IP address fed back by DNS, and then it'll show us the hops in the path. Let's check it out. All right, final moment here. Oh my gosh, I love it. I love it. And I love the fact that anybody can practice with things like this and get it working. And there's 3 options that are important. This is part of the, the Keith Barker channel's objective is to give you the tools and tips today, helping you get your CCNA. And one of the tips is lab, practice. Because you saw me come across several things like, oh, this isn't working, why not? And then troubleshooting it and walking through it. That type of experience is going to go a long way in getting you to getting your skills up and up and up. So I'd encourage you, here's my call to action. Please take either a physical lab environment that you have at home or the Packet Tracer Lab. You can find that in my master playlist or my Packet Tracer Lab files. Or if you have Cisco Modeling Labs, I'd like you to try this as well in practicing getting hands-on connectivity from a home lab out to the actual internet, which is super fun. And if you haven't already joined the channel, please do so. Please click on subscribes. Don't miss a single thing. Get the latest tips and tools regarding earning and getting your CCNA. It's fun to have you here. We usually have, right after a live premiere of a video like this, we often jump in the Discord server. So if this is the live premiere day, we'll do that as well. So right after the premiere, please jump on the Discord server. I'll have a link in the description. We have a voice chat, a CCNA voice chat, so you can just listen, hang out, chat. It's all fun. And then also on Sundays at 11 a.m. Pacific time, so get out your world clock calendars to adjust that. But at 11 a.m. Sundays, we are doing quiz questions. And it's sort of like the marriage. Imagine a really fun game and flashcards based on CCNA getting together. And that's what we do using Kahoot. I can only support up to, it's funny now, but I imagine at some point we'll meet capacity. We can support up to 2,000 people in those games. And my intention is for everybody who wants to participate, have a lot of fun, get some reinforcement of those concepts, join us. It is free. It doesn't cost a dime, as do these videos here on YouTube on the Keith Barker channel. And this is meant to be a resource that you can use as part of your CCNA studies, again, to give you the best tips and tools today regarding getting your CCNA. So I'll see everybody in the next live event. Until then, have a great day and happy studies. Bye.
Do you ever feel you don't get out what you're putting in?